Welcome to this webinar series from CREI, the Collective for Reimagining Engineering and Innovation. And this week we have Dr. Jayachandra Bengi to speak to us on his experience with bio-inspired design. And before I jump into a brief intro to Dr. Jayachandra, a quick recap on the type of talks that we have been hosting as part of CREI. There are three categories of talks which we have been hosting. The first is talks relating to any experiments in engineering education. Second is talks which are related to product development experiences in the industry. And the third one is research labs and research centers and ecosystem development activities carried out by faculty. So these are the three categories. So today's talk will probably fit into both the engineering education as well as the research lab related categories. So let me briefly introduce Dr. Jayachandra Bengi. He is assistant professor with CREI Kanchipuram, the School of Interdisciplinary Design and Innovation. He has done his PhD from IIT Madras in photonics and postdoctoral from NTU. And as part of his work in CREI, he has also set up a research lab called Bio-Inspired Research and Design Lab, which combines the bio-inspiration and photonics to look at product development opportunities in both defense and medical devices area. So with that brief introduction, let me invite Dr. Jayachandra Bengi to share his experience, and over to you.
Yeah. Well, thank you, sir, for inviting me for this talk series. So let me share my screen. So hope the screen is visible to everyone. Let me introduce the laboratory which we established in CREI Kanchipuram. That is Bio-Inspired Research and Development Laboratory and Photonic Devices and Sensors Laboratory. It is a single laboratory. So really what we are doing here is we are using the photonics as well as the bio-inspiration together to make the different products realized. For product development, we are using these two as tools. So that is about the laboratory. And today's talk title, as mentioned earlier, Nature to Venture, a Path of Innovation. In this, I would like to explain first of all a case study, how my journey continued in a particular project, and later I will introduce different achievements from the laboratory in the last 4 years. So at the same time, I'm also going to address 3 questions related to the bio-inspiration. One is, should we start with the bio-inspiration and go to define the problem statement? Generally, people start with this question. And second question is whether we have to choose the problem and then go for bio-inspiration. And third question is whether we are going to, in order to do the bio-inspired innovation, so there should be any special capabilities, or is it in a easiest way can we achieve the innovation using the tool called bio-inspiration? So these are the 3 different questions I'm going to address in this particular talk. Let us start with the first slide. Hope my slide is changing.
Yes.
Yeah. So in this first slide, you can see 4 different photographs which I took in CREI surroundings. Generally, nature means our perception is always and most of the time related to the beauty. So this is the general perception about the nature. That means first photograph, if you see, you may remember it appears like a galaxy. And second photograph, you may appreciate the color combination. In the third photograph, I don't know whether people can see that or not. You can see a very good smile there. which include the sun. At the same time, we can also see different interactions of natural elements. Here, leaf and waterlets there. So this way, our perception, general perception of the nature is related to the beauty, and second is the pleasing feel it create in our mind. So this is the general perception. So, but here in our laboratory, what we are doing, or generally what is meant by bio-inspiration, is we are going one step beyond that, the perception of beauty, and we are trying to experience it and understand it. And based on that understanding, we create our own knowledge and then we build things. So let me start with this saying from the Viveka Chudamani. The reality can be experienced only with the eye of understanding, not just by the scholar. That means just by sitting and use my scholar or imagination, I'm not actually going to build things. To build things, and there should be a holistic understanding which is included with our own experience. So this is what the meaning. So now I will start with something that a general thing is, I read a book about the grasshopper. Then I keep lecturing my mother that this is the grasshopper, and some 8 legs will be there, and this is going to fly like this, and many things I will tell about it because everything is there in the book. When I ask myself, is this book reading enough to tell about the grasshopper? The answer is no. Suppose if you want to really understand the grasshopper, maybe we have to go ahead and implement some processes to interact with the grasshopper in different ways. So I'm not saying that immediately you have to catch the grasshopper and kill it. I'm not saying that. So, but in different ways, you have to interact the grasshopper. You have to observe it in different ways. And that interaction, you can start with, let us assume I'm sketching a grasshopper. So if I'm sketching the grasshopper, what basically I'm doing is, I am actually realizing what is my understanding about the different parts of the grasshopper. So different legs, how they are oriented, and I can show these things just like this. Suppose if I increase my perception little bit more, or my understanding little bit more, maybe I can paint different parts along with the colors I observed and surface textures, and there are the features, micro level features, which we can observe in the grasshopper closely. So now I'm able to paint it also. Now let us go one step further. We will implement another process called photography. Now what I'm doing, I'm actually taking the photographs of different functionalities, what it is actually doing, what grasshopper is doing, how it is flying, how it is jumping from one point to another point, how its orientations are changing, how legs are working. These things actually I'm going to capture using my camera. That means photography is a tool, but what I'm really observing is the grasshopper's functionalities. So after this actually improve my understanding about the grasshopper little bit more. Then I will actually jump into maybe taking videos, the same grasshopper in the different conditions. In the different conditions means in the grass, how it is going to jump. So I'm interested in the functionality now. How it is going to jump in the different condition like sand. So these are all processes, that may be sketching, that may be painting, that may be the photography, that may be videography. These are all tools I'm implementing in order to interact with the grasshopper. So the first step of bio-inspiration is, can I use different tools and interact with the biospecies or the biosystems? Once I start my inspiration, once I start my interaction, my understanding will be at the different level if you compare with the reading book. That's why the next question, if you see how my experience is different from reading about it in a book. So my experience is very different because I might have observed or I might have appreciated very micro level details or very micro level details related to the functionalities, that may be behavior or a form in different aspect. Now my understanding is different because of my interaction with this grasshopper through different tools. What I'm actually doing here is the purpose-free exploration. I don't have any purpose actually. I don't want to do anything with the grasshopper. So this purpose-free exploration is actually creating a knowledge in me which is unique to me. So this is the basis of bio-inspiration up to this in the last 5 years. What I understood is we are actually creating the self-created knowledge about the biosystem through the interactions using these different tools will create some knowledge within. This knowledge, when you already built some knowledge on your own, which may be available, may not be available in the book. Because in a book, you can't actually tell about the different aspects of the thing, and micro detailing cannot be done in the books. So this needs the experience using different tools, different interactions using different tools that actually build the experience, which is actually creating some knowledge base in you. Up to now, actually, I don't have any purpose in doing this. This is just like a hobby. Now, what I'm doing is, if somebody asks me, do you know, after doing all these things, somebody asks me, do you know everything about the grasshopper? My answer is no. And I don't worry about it. Because why? Because I can clearly say that I may not know everything. In order to know everything, maybe I need extra skill or some more exploration using different tools. But the minute I build the knowledge, my own created knowledge, immediately I start thinking about how to manifest this knowledge into something. It's a natural tendency. So the tendency in the innovation, actually, when somebody is working in the innovation, if you build your own knowledge, the natural tendency towards you want to create something out of that knowledge. Now what happens? You are going to see your surroundings, your society, or something else, or you are going to observe something in the society with this background. So in 2022, what I saw is the soldier, maybe some competitions, running 180 kilometers in 6 hours. He won that competition, Indian Army soldier. So in this, actually, two questions raised. Can he run 180 kilometers in same 6 hours in the desert conditions? Second question is, should they run this much? So should they run this much means, one way, actually my basic knowledge is making me to think in the direction that should they run like this, because I want to give something to them, make their running or walking augmented. So now my exploration is started with the purpose. So now purpose driven exploration is started. So after purpose driven exploration, what is my target? Now I am going to experience the grasshopper in the perspective or the direction of this. So now I want to experience the grasshopper. I want to generate the experience in this direction. So now I am interested in the functionality called running. So now my exploration became function-driven exploration. So when I see this function-driven exploration in the biospace, that means to search for the bio-inspiration with respect to the function, I am going to widen my knowledge base. I am not limiting myself to the grasshopper. I am actually expanding my base in the biospace with the different inspirations and species. So this is the process happening, in my opinion, when we come to the bio-inspiration. So once we choose the functionality, this model everybody know, this is the general theory and model in design. When we choose the functionality always related to its supportive structure and it's a fundamental or basic mechanism that is supporting the functionality. So structural behavior and connection-based behavior, that is, I can say it as a mechanism. Here what I mean by behavior is mechanism which is the basis for this functionality. So my journey started with the function. Now that function, I clearly know according to this FBS model or bio-inspired FBS model that this is always supported by the structure. And this is, every function is based on some fundamental mechanism within the system, which I call it as behavior. So when I realize this, according to my interest, that is augmented walking or augmentation to running. So the excess ground force to augment the walking and running is my requirement. Then I'm actually emphasizing on the functionality, so impulsive reaction force from the impulsive reaction force to the foot. Now the inspiration I found here is not the grasshopper, but its name is flea beetle. So my inspiration is changed because I'm interested in the better way to achieve the augmentation in running or walking. So flea beetle is my inspiration. In that, I found the structural support to this functionality and the behavior or basic mechanism, which is the basis of this functionality. So this I'm going to study. So when I'm studying that, if you see in the flea beetle, you see the natural gear system in the flea beetle. So maybe we are thinking that this maybe wheel as well as the gear system we invented. Maybe there is a natural gear system already exists in the nature that we find in the flea beetle. So in this flea beetle, actually this system is going to use this gear system to generate the impulsive force, which making it to jump in a very efficient manner. So when we understand this basic mechanism, we start, that means you can understand that I know about the functionality. Now I know about the basic mechanism. Now I know how structure is supporting this basic mechanism. When I know that, now I am going to conceptualize the model for my solution. So here I have shown on the screen that how flea beetle, how I am understanding. So here I always say, maybe my understanding is different to that of yours. So here my understanding is this one. So that means two gear systems are there as shown here. Then springs are there. Then I am actually imagining this system as this. So which is shown in the A. So this is the 2D system. So my evolution go from 1D to 2D to 3D. Definitely I can imagine the spring system. So when we go for making the models before the prototype. We started with the paper. So this kind of things, it's kind of a structure which will regain its shape. You can see here in the A. At the same time, we modeled and simulated it, and we found that here one important parameter that is theta, and d is the diameter. Especially theta really significant for this kind of structure. First, we went for the 2D structure, which you can see here in the red color here. So first we realized this one, E, and we thought that it will work in only one direction. We want to upgrade this to the 3D. In 3D also, when we simulated, actually the solid system is working better than the hollow system. So in this hollow system, even though the angle is actually significant, but it is not withstanding the higher forces. So we went to the solid systems. So in this solid system, which I call it as jumper, this according to this angle 90 degrees, which is the normal angle, and this is the higher angle jumper. So this is what manifests. So I started my journey from understanding the flea beetle with respect to functionality of jumping. After taking the functionality into consideration, I understood the structural support. Now I understood the basic mechanism. Now I imagined something in my mind. So that is where the biomimicry and bio-inspiration may differ, may go in different ways. So I don't want to replicate that system, but I want to get inspiration and create my own system the way I want. So this way, with respect to the normal angle and the higher angle, we created this the system called jumper. Now this is the path. We started with the inspiration. We made 2D, then achieved 3D. Now we found another inspiration, which we call, this is called springtail. So its jumping capabilities are really great. So that we are now trying to implement or introduce into this system, like a multi-inspirational system. Now, if you see the testing, I don't take much time. Here, if you see wooden plate, when we give some megahertz, it's the output is in the accelerometer is 1861. But when we use the low angle jumper, this is actually reduced. And when we use the normal angle and higher angle jumper, the vibration is enhanced. So this is what significant thing, that means maybe new thing, we observed that just by varying that angle, we can actually make it as a vibration isolator. At the same time, we can make it as a vibration amplifier. That means more ground force we can create. So this is the testing. Now I need to define what is the option for venture. That means I have to take it to the product level. So this spark shoe concept, we call it as spark shoe, where we want to mount these jumpers into the shoe. Of course, first prototype, you already did that. Now I want to define it for fast walking or running shoes, because these are removable. That's why we need not to worry that I have to always, we need not to wear this. So whenever we need this fast walking, we can wear this. The second, another kind of shoe is shoe with acupressure jumpers. So we will create the required pressures. And the third way, which we are about to realize now, is removable micro shock absorbers for vibration isolation tables. So these three we actually defined as the outcome products of this particular jumper. That means we can use this jumper in different system. One is as a vibration isolator, if it is the smaller angle, and if it is a larger normal angle and a larger angle, I can use this to amplify the vibration, that is to give more force. which will actually augment the walking or running. So this is what we created. So this is what the case study or the journey which I wanted to present. So now here I simply, it is not like that I build something. Now I have created a knowledge and I am proposing different products out of that. But actually the idea started from the bio inspiration. So this is one way. That means I will generally start with the functionality and go ahead with making something and defining the different applications. The second way is we can see this one, the in the snake inspired system. This particular work started with the fact that we saw in some Israeli scientists did some experiment. So in the experiment, what they did is they mixed some kind of poison in water, and pure water they have taken, and they kept pure water and the poisonous water, which are more or less transparent. Both are almost same. So they left the snake from the different conditions where it required to drink some water. It naturally detected the toxic water and it drank only the pure water. So that is where, after reading that, only this journey started. We wanted to understand the vision capabilities of the snake. Now, here also, if you see, I am actually choosing the inspiration. From that, I am building the technologies. That means inspiration to problem to solution. This is one way. So here we have chosen that, we studied that. What we understood from this is its ability to see the mixed signals and see through the surfaces. So when we saw that, see through the surfaces means it is, we have a technique called multispectral image. So in India, if you see, the bit costly technique. So in the multispectral imaging, we have to use the spectrometers, but snake is not using any spectrometer related technique or something. It is purely using its vision in the UV regime, little bit of visible and IR region. But its a way of understanding is all three eyes. It has, I can say it has three eyes. So two eyes will see the UV and visible. The other pit organ, we call it as pit organ. That organ sees the infrared radiation. That means it is understanding the environment, or it is understanding the any object with respect to three eyes, and these three eyes are working in a combined fashion, in a synchronized way. So because these are working in a combined fashion, it can understand the mixed signals. So its perception is very different. So that's why I named this device as compound visual perception device. So it's a compound visual perception. So how it is perceiving the environment is very different if you compare with the human vision. So in this, the first application we defined here is the well-known the problem in the aerospace engineering, that identifying the rust or corrosion under the paint. So rust or corrosion under the paint, that means when the paint is above, there is no signature of the corrosion. We need to find the rust just beneath the paint. So this is one problem. We actually get it clarified from the National Aeronautics Limited also. They helped us in this case. So in this case, we implemented this device, which I call it as a CVPT device or Nag Drishti. So in this Nag Drishti, we used different cameras in the different spectral regimes, and we used some very simple analytics to process the image. Now here you can see the plate which we painted. Now the surface, if you see, surface very clearly painted. There is no signature of any rust. But under this, we intentionally introduced the rust. So that if you see the images here, the grayscale image and contour image and heat map image, the middle portion, white color portion in the contour image, clearly indicating wherever we induced the rust, this device is able to perceive that. So with this, actually, we got convinced that in snake, definitely we have a different kind of perception that is definitely very significant for developing the technologies. So still we are in the starting point, maybe. So this application we defined and we successfully found that the corrosion under the paint. The thickness of the paint, we went as per the thickness given by the National Aeronautics Limited. And after that, they gave another target that if you intentionally grow some oxide layer and then paint on it, so that means you already have the rust. Can you actually see the changes in that layer? So that target we are exploring using this technology. That means what we did here is summarizing this. We actually understood what snake is doing to perceive the environment. We didn't mimic it as it is. We are actually understood how snake is understanding the environment or the different objects. So it's perception. If we understand, we can actually create that kind of technologies. So this is another example where we started with the inspiration and went for creating the solutions. Now the same technology we are applying for different applications. For fruit and vegetable quality monitoring, we are working with Vehicle Food Products Private Limited, Chennai. And a neonatal bilirubin detection. This is for jaundice detection. So this we are working with our own student, that is Refractex Private Limited. So this way, from the inspiration, I'm creating solutions. Then I'm going to, I'm taking them to the commercial level. Next, this is the second case study. Where we have taken inspiration from the fire beetle and the silver ant. So this is also, but this started with a problem. So our problem is the heat here, everywhere. So in order to reduce the heat is the bigger question or bigger problem for us. That's why we have chosen these biospecies, and these species actually having the ability to tackle with the high heat conditions, higher heat conditions. That may be silver ant. This is the silver ant you find in the desert areas. It can survive in 100 degrees. It is the fire beetle. You know, this beetle actually can create the light where immense high amount of heat is generated. That heat itself, it absorbs itself. It has a particular structure to absorb them. So one way it is absorbing the heat, other way heat is surviving based on the reflection of the heat. And if you see these silk cocoon having the very good capability to regulate the temperature with you. So inspiring from these all things, we created a technology called cool patch technology, where one way we created a structure. It is in the final stage now. In next 1 month, we are going to complete this. One side, it will absorb more, other side, it will reflect more. In between, we are using some material so that we can actually use this heat into different purposes. So we call it as cooling patch. I think here 300 degree, it's not 300, it is 30 degree. The silver and fire beetle inspired cooling patch. So 5 to 7 degrees centigrade, it can reduce. It's already tested. And it is working well above 29 or 30 degrees. So if you go below 30 degrees, maybe that reduction will go to 3 degrees or 3 or 4 degrees like that. So, but above 30, it is working very efficiently. So one of my student who is in the today's audience, Vlog Innovations LLP, Mr. Lokanathan is taking forward. He found some gap between the ceiling fan and the air cooler and our AC, air conditioning system. So he want to reduce the load on air conditioning system using this kind of patches. So this is purely based on, I started with a problem. I want to reduce the temperature in the closed environment. I want to regulate the temperature in the closed environment. At the same time, I want to use this heat for different purpose. So for this, we created this technology. It is purely started with the problem to inspiration to solution. Then these are the different technologies, other technologies taken forward by Vlog Innovations. And one is, here we have taken only form as our inspiration. To accommodate this sanitization process here and the sliding system. So here we didn't use any, this is the Litsan is the sanitization chamber built for grocery shops. So here we didn't use any conveyor or something, but this form only taken as inspiration. At the same time, other thing is, from nature, we learned that nature also can do the water purification. In nature, it is using very small processes which mutually support each other into single big process, and it can purify the water. Even in some forest, we are able to find this kind of natural purification systems. So that idea we have taken, then we developed the first, this is the first prototype of the E-Light Pure photo-induced electroabsorption based water purifier. Here we are using that kind of system. So here, what I want to say is, we are understanding what that process is fundamentally. If we understand that, we can mold that into any manner so that we can develop the technologies in different directions. So now the last question is whether this kind of bio-inspiration can be performed, because I told you have to understand through the interaction by using different tools. But is it need high IQ, because high IQ or understanding capability or different things? So my answer partly is no. Because we what we did in this direction is, in order to make this process very simple and systematic, we connected this bio-inspired innovation to the standard method called TRIZ. The TRIZ method is well known in the innovation domain. So the TRIZ means the innovative method for method for innovative problem solving. So in this, we attempted a problem to solve. So what was the problem? The problem was to identify the underground tunnels. And we used the TRIZ method, normal TRIZ method, and we found a solution statement. And we used that solution statement to identify the suitable inspirations. That suitable inspirations emerged as, before that I didn't know about this worm. This worm salamander is very interesting species. I came across 6 months back. This has optically sensitive skin. That means my sensor is not pointed sensor. Now my sensor is 2D, like our skin. So my sensor is 2D, according to that TRIZ solution statement, the sensor should be 2D and elongated if you want to detect something underground. Exactly, I found this species dwell in caves, and according to some reports, it can detect the earthquake 2 days before. So I don't know whether it is authenticated or not, but there are some reports saying that it can detect vibrations very, very efficiently. This is the cave dwelling species. At the same time, we know the well-known this earthworm. The earthworm is the recent experiments on the earthworm surface indicating that the earthworm surface can generate the Faraday-like waves, body waves, which can enhance. Body waves means, suppose if your wavelength is lambda, you will have extra wave at lambda by 2 also. That means your sensitivity will increase. So in order to increase the sensitivity, or in order to bring the new kind of sensor, which is a kind of a skin to determine the seismic vibrations, to detect the underground tunnels, or maybe kind of earthquake prediction. So once we went from TRIZ method to bioinspiration, we clearly observed that we are actually finding new kind of species or new kind of inspirations which we didn't know. At the same time, our solution also has improved a lot. Now, based on that inspiration, we actually realized this. We call it as the spy worm. The spy worm, this is a kind of a rubber kind of material coated with the silver. Initially, the material we have chosen is silver because we are using some optical system inside to make this more sensitive. It's kind of a cavity now. So now that cavity idea came from, again, this earthworm. But because I'm anyway doing on photonics, so I'm using the photonic approach also. If you see, if you keep in open environment, there is no sensitivity. But when you take it to the closed environment, that means if you bury it and keep it in the closed environment, the sensitivity is increased. It is able to detect the vibration. This tested in our campus initially, and this is in the phase 1. So still we are developing into the next phase. So this way, we started with the problem and defined it in a systematic way. So bio-inspiration now I can't say it is random. So you can use systematic way like TRIZ method and use the bio-inspiration, connect the bio-inspiration to the TRIZ method. Now bio-inspiration became systematic. So these 3 approaches are possible. That means inspiration to solution, inspiration to problem to solution. At the same time, problem to inspiration to solution. And you can connect bioinspiration to the TRIZ method and make this method as a systematic method of innovation. So these are the different things we did, and these are the different products and prototype made in the laboratory in last 5 years. Still, we are taking them to next level. So other types of devices are related to pure photonics. So that's all about this talk. Thank you very much.
Thank you, Dr. Jayachandra, for giving an overview of both the bio-inspired design and a range of inspirations and products. So now we'll open it up for questions from the audience. So audience, if you have any questions, please unmute and you can ask a question or post it in the chat.
Can I ask a question, Sudhir?
Yeah, please go ahead.
How do we discover these capabilities of these biological capabilities, like the example you mentioned of the salamander being able to detect the vibrations and so on? I mean, these are properties which are not easy to find someplace in one place. And that's going to be a big challenge. Give us some insights into that, addressing that problem.
Yeah. As far as that question is concerned, sir, our biologists created very vast knowledge base. I have to say and agree that. So we have already existing vast knowledge in the biological platform. Only our maybe engineering people are not tapping it. So this bio inspiration now, generally how they define is, now it is actually connecting the biologist with engineer. So that way, the existing knowledge, a lot of existing knowledge is already there in the biology. Only thing is, like some platforms are there, like Ask Nature. So in the Ask Nature, suppose if you know one particular functionality you are interested in, so I'm interested in, then I can go directly and search in the Ask Nature with respect to that functionality, so that I can get some related inspirations there. But still that platform is growing now. It's not the final, it is not in the final stage. So Ask Nature we can use, that is one. But if we search randomly with respect to function, maybe we have to put some extra effort to find the suitable inspiration. But biology related, the lot of information already exists.
Yes. Thank you.
There is one question in the chat box, which is more like, I think you addressed that, but it is more related with whether you start with inspiration first or waterfall model and things like that.
How many of these technologies have you patented to? Now it went to seven patents.
There are a couple of other questions before that too. Yeah.
Yeah. What water purifier constructed of? It's presently 3D printed water purifier. Within the water purifier, we have different processes. It is like a mutually supporting process. That means one will enhance it. So presently it is made of the 3D printed materials. Inside we used normal electrodes, metallic systems, metallic materials.
Can you tell us a little bit more about the water purifier and how actually you gave a general idea of how it works, but
yeah,
in a little bit more detail on how it works?
Yeah. So the water purifier, if you see, this we started to purify the fluoride ions. The first target was fluoride. Because fluoride, we have a lot of problem in India, different areas. And fluoride also very tricky element, that it is very small. And even RO system also, sometimes this fluoride can penetrate through. And lot of wastage is there in the existing RO systems. So we wanted to make a non-RO system. At the same time, we wanted to filter out inorganic contaminants also. Non-RO system and inorganic contaminants also. Organic contaminants, anyway, we use deep UV light in order to eradicate those germs, all those things, microbes, all those things. But here we wanted to see some processes which are supported or enhanced by this UV light. That's why we went for photo-induced electroabsorption. So when we went for photo-induced electroabsorption, we saw very efficiently it is absorbing fluoride ions. And we saw that even other inorganic ions also got absorbed in this. And this power, actually, we optimized in such a way that we can generate our own power. That means the electrode system is made in such a way that you can generate the power to purify the water. So that's why we made it as a self-purifying water bottle. That means the power you can generate within the 10 minutes is sufficient to purify the 250 ml of water in this water bottle I'm saying. So one process is photo-induced electroabsorption. That means my UV light not only kill the germs or kill the microbes, but also enhance the absorption process. The second thing is water having the natural capability to purify on its own if it is charged. So the charged water concept we brought into this so that the charged water will actually coagulate some kind of impurities. If some solid impurities are there, it will coagulate them. At the same time, in the presence of the charge, this adsorption will further improve. And we found that there is a possibility to make the water charged more and more using the UV light. Now, if you see, the UV light is connected to adsorption, adsorption is connected to charged water, now charged water connected to light. So these all together we are using to absorb more and more inorganic contaminants as well as organic contaminants. Yes.
Very nice. I just thought that people may want to know the mechanisms that are connected together.
Yeah. So we connected them. It's like a cycle.
Yeah.
And we made into a bottle. Nature is actually exactly using this kind of strategies. One process will support other, but these small processes will come together and make a big process, and they are achieving something.
Okay.
Could I ask a question, Sab? Another
Sure.
one.
Please.
This is very inspiring talk, Professor Bilgi. So I cannot help asking. I know it's kind of a fashionable thing these days to ask about AI, but given the vast databases we have about biological phenomena, organisms, and properties, I wonder if the first step that you mentioned of identifying relevant biological processes is being helped by use of AI techniques. Sorry, it's a fashionable question to ask these days, but I can't help asking you this.
So for AI techniques, you are asking, sir?
Yes.
Yeah, AI techniques, yes. They are using the bio-inspired algorithm development that they are using. Basically, AI is bio-inspired. Because in the neural network, if you see, the neural network is bio-inspired.
That's right.
Yeah. So there are several works they're doing. Maybe in that direction, still I didn't start my work. So,
So I know of something.
maybe I can help in finding the suitable, because for example, some ant colony optimization is there. Then swarm algorithms are there. So like this, I can help people to find the suitable inspirations and I can work.
So one thing I wanted to ask along these lines is this, that yes, you're using bio-inspiration, and especially I think the more important thing is multi-sensor composition as a way, multi-sensor or multi-process composition as a way to solve problems, and which is clearly that itself is bio-inspired in the sense nothing bio works by itself, right? So my question then is, besides what is available in nature or in the Ask Nature and other places, just looking at the surroundings around you and the animals and various other things that exist,
yes,
we can always find additional forms of inspiration. So what I'm getting at is observation as a critical point as part of your exploration. yes, there is literature, but beyond literature, your own inspiration comes from looking at things. For example, an anthill is one of the coolest environment inside
Exactly.
because of the
Exactly.
way the airflows take place. So what I'm getting at is, for to be an engineer, you need to figure out what the world has engineered already, the nature has engineered already. Right? It's that kind of an observation power that we need to get our students to imbibe.
So that's why, sir, that is where I actually distinguish biomimicry and bioinspiration. Suppose if you say anthill, can we understand anthill or some process involved in the anthill which is making it to achieve the more temperature stability? Can we understand that process fundamentally what it is? We have to understand it in a very generic fashion so that from that we can develop many things.
Sabir, is there another question, or can I
No,
ask?
go ahead. Go ahead.
Okay. This is a broader issue about our education system and the curriculum. Long ago, when I went to school, I had to make a choice in 11th grade whether I'm going to learn biology or chemistry, physics, mathematics. Biology for doctors, chemistry, physics, mathematics for engineers. Is that still the case in curriculum in Indian educational system, or is it more possible for a young student to learn both, who's preparing for engineering or going to engineering education, to learn about biological domain? It was not possible at that time, but that was long ago.
I think this question is Sudhir sir's question, not mine.
So in terms of, if you look at the central board's syllabus, there is option available for science stream students to do both math and biology, right? But there is also options available where people can only do the physics, chemistry, and maths streams. But this NEP is supposed to address some of these issues, create more choice and all. That is one side. The other side, within the engineering colleges, now people have started reintroducing biology in the first year, so that students have an option to relook at the biological side of it also.
Thank you.
So when I studied in Delhi in the 70s, we had both. Even if you took the biology stream, you had to do physics, chemistry, math, and biology. That was only available during the central board education, but only in Delhi, nowhere else at that time. That's
no, even today CBSE offers that one stream has that flexibility to do both. But in general, state boards and others, there may be a more distinction between these two. But the national education policy essentially is encouraging people to relook at that. But it will take time, I think, to get it streamlined. Okay, I think we have come close to our time. So if there are no more questions, then
I think Mr. Hari Krishna asked some question, but question is too big.
Well, basically, he's asking you, is bio-inspiration a one-step process, or the system itself evolves over time?
No, I can't say it's a one-step process, but in order to innovate, because I'm talking bio-inspiration in the innovation perspective. So it is a multi-step process. It's not single step.
So I just want to mention two things. One, I know a person in James Madison University. You are using FBS as the theory behind it, whereas she uses CK theory as the basis for identifying and I will request her to give a talk in our forum so that she can tell us. She has done quite a few experiments with undergraduate education, bio-inspired education using CK theory. And I will ask her to give a talk maybe in the next month or so, okay, which will be a complement to your talk, because you are producing artifacts. What she is doing is she is using the classroom as a way to design the artifact using CK theory for bio-inspired. Thank you really very much for this talk. Sudhir, any closing thoughts, and then we can close this talk.
Next talk, do we have the next
talk?
talk?
Yeah, next talk.
Maybe you can announce the next talk.
Yeah. 2 weeks from now, Professor Rajagopalan from IIITB, he's retired from there, but he has been heading a project on open source unique identifier for people, similar to Aadhaar, but it is an open source system which is being implemented in several African countries and Indonesia and so on. He would be giving a talk on that whole process of developing such a software, the model, the other aspects of how they have gone about building the system and distributed it to many parts of the world. Professor Rajagopalan will be the next speaker in 2 weeks' time.
October 18th?
Yes, October 18th. Thank you.